So today we'll be doing JunYuan Secondary School 2021 paper, Chemistry paper 1. So the first question that we see here, okay, lead is insoluble in water. So we know that this is actually a solid in water. It's prepared by adding aqueous nitrate to potassium iodide. So this will mix to form potassium nitrate and lead iodide. Okay, and we know that potassium nitrate is actually aqueous. Okay, and then our potassium iodide, potassium iodide is actually a solid. Okay, so preparation and this, so we know that it's a solid, so it means that it must be some form of filtration involved, right? So we do not need this is to evaporate to dryness. Okay, don't mind my handwriting. This is a beaker, is just to contain. Okay, this usually we will put the flask over here, or the inverted filter funnel here, right? So be like that, then the filter paper will be lined inside. Okay, this is the to measure mass. Okay, and then this is our filter paper. Okay, paper, and then this is our funnel, filter funnel, or write funnel for short. And then this is the measuring cylinder. Okay, so bear in mind that this is actually 20 cm cube. They wrote it in 0 decimal place. So this means that the measuring cylinder is suitable and appropriate to measure the volume. If, let's say, for example, they write it in 2000 cm cube, a measuring cylinder would not be applicable or suitable in this situation. Okay, so then you have to use a burette. Would be better. Okay, so in this case, we will definitely need to use one to contain and store the filtrate. Filtrate is the thing that's coming out of this. The residue is the thing that is remaining, the solid that's remaining. Okay, so in order to contain the filtrate, we need this. We need number 1. We do not need 3 or 2 because we are not measuring any mass. We definitely need 4, so, and 5 to measure 20 cm cube. So the answer should be 1, 4, 5. The answer should be C. Okay, some of the substances are mixed like that. Okay, so for this type of questions, for these types of questions, okay, you just use a ruler in an exam paper. However, this is on the iPad, so it will be difficult to measure the length. Okay, so what I would do, I would just eyeball it. Okay, because 0.38 is actually a ratio, so I'm using the ratio of this to the ratio of this length. So I'll just eyeball it. Maybe around 0.38 should be around here, where this is about a third, close to a third. Yeah, about a third of the total distance from the start line to the solvent front. So the answer would be B if I eyeball it. Okay, but usually in exam we will use a ruler to measure using the actual dimensions and whatnot. Okay, this is actually, okay, so first of all, when you add dilute nitric acid, okay, this room temperature, just to recap, room temperature is 25 degrees Celsius and atmospheric pressure is 1 atmospheres. Okay, to acidify with dilute nitric acid, so there's no visible change. So it means that there is no effervescence. Okay, so it means that whatever is there is not a carbonate. It's also not a form of metal. Okay, it cannot be a metal because it's a compound. Okay, aqueous solution is also aqueous. It can be a carbonate, it can be sodium carbonate or potassium carbonate, but it cannot be a metal. Okay, so it's definitely not metal. Okay, for identity of X. When you add nitric acid, there's no effervescence, so can it be carbonate? It cannot be carbonate. Okay, can it be sulfate? Because this is a test for sulfate test. Can it be sulfate? No, it cannot be sulfate. Okay, so it's either calcium nitrate or zinc chloride. Which is the correct answer? Take a look at the second one. Add aqueous ammonia. When you add aqueous ammonia and there's white precipitate, this will indicate that it will be either aluminium or zinc. Okay, calcium is out of the list already because there's white precipitate. Calcium would not produce any white precipitate in aqueous ammonia, so it means that it's either aluminium or zinc. Okay, aluminium or zinc. Okay, zinc. Okay, is soluble in excess, so it means the answer should be zinc. The answer should be D. Okay, gases are separated from liquid air by fractional distillation. Okay, boiling points of 4 gases are shown. Okay, these are monoatomic, so we know that nitrogen has a triple bond. To fulfill its octet electronic configuration, so it has a triple bond. So this is definitely out because this is actually a diatomic molecule. Okay, neon is actually still noble gas. So these are all noble gases, so hence they will exist as a monoatomic element in the atmosphere. Okay, so it's a liquid at negative 200 degrees. Let's draw the temperature. Okay, negative 200 degrees Celsius. Okay, so what goes behind negative 200 degrees Celsius will be negative 269, negative 246. What goes in front will be negative 186. Okay, so this at this temperature, at this particular temperature, okay, this is actually a liquid. So it means that the must be the boiling point. So basically 200 degrees Celsius or negative 200 degrees Celsius must be lower than the boiling point. So in this case, it will just be obvious. It will be 186 degrees. So the answer would be 8. Okay, the answer will be 8. Next, we are going on. Hydrogen gas is this. Okay, we know hydrogen gas has a molecular mass of 33.5. Relative molecular mass of 33.5. So this is ammonia. This will be HCl set up here. Okay, solid ammonium chloride or solid ring or cloud will be formed in this case. Okay, so the experiment is repeated using hydrogen bromide. Okay, which we know that this is actually a molecular mass of 80, if I'm not wrong. Relative molecular mass of 80. So it's definitely heavier. Than hydrogen chloride. So this means that hydrogen bromide is 81. Hydrogen chloride is 36.5. So we know that hydrogen bromide diffuses at a slower rate. Just remember that if something is heavier, it will diffuse at a slower rate, because again, if something is heavier, you need more energy to pull something across the room. For example, if I have a big stone versus a small stone, and I ask you to drag across the room, which one you drag across the fastest? It will be the smaller stone. Okay, so the bigger stone will be dragged across the room at a slower rate. So that's the same idea. The diffusion rate will be slower because it's heavier. So we know that HBr or hydrogen bromide will diffuse at a slower rate than hydrogen chloride. So means if hydrogen chloride diffuses at this distance, hydrogen bromide will definitely diffuse at a shorter distance in the same amount of time. The keyword is the same amount of time. Okay, but in your open-ended question, it's always important to write in the same time frame. It diffuses across a shorter period than something else. Okay, so the answer should be A. Okay, yeah. Okay, always feel free to pause the video to analyze. Okay, number of particles, nuclei of 4 atoms. Okay, which 2 particles belong to the same element? Okay, this is very easy. Anything that belongs to the same element will have 2 protons, 2 same proton numbers. Okay, basically these are what we call our isotopes. Okay, isotopes can be like that, such that the electrons are different. Okay, but yeah, so that's about it. So answer should be 2 and 3. So answer should be C. Okay, so an element has a proton number of 20. We definitely know that from this it will be calcium. Okay, and to check, yes, calcium has a nuclear number of 40. Okay, X reacts with element Y. So X is actually a metal, so this will be a non-metal. Okay, because it will form an ionic compound. Okay, so since X is a metal, it will form positive ions. Okay, again, calcium is negative what charge? It has 2 valence electrons in its valence electron shell in the calcium atom. So it will have to lose these 2 electrons, right? So essentially it will form positive 2 plus charge and 2e minus plus 2e minus. So it will lose the electrons. So this is the atom, which will look something like that. I draw it like that. I don't know. Yeah, it will look something like that. This is the atom. So it will lose 2 electrons. So then I have smaller ones inside. 20, right? 18, 18. Yeah, it will be something like that. 2, it should have 1. okay, quite a few. Let's redraw it. 1, 2, 3. Oh. Oh, okay, it'll be something like that. Okay, then when it loses 2 electrons, it will become just 3, where all of these are fully filled. Okay, this will be my calcium. Okay, so it will lose 2 electrons, so the answer should be D. The answer should be D. Okay, a covalent molecule M contains a total of 4 shared electrons. 4 shared electrons. Okay, total of 4 shared, not 4 pairs, but just 4 individual electrons. Why is M? Let's draw this. Okay, definitely not ammonia, because ammonia only shares 3 maximum, so this is definitely out. Hydrogen chloride only shares 1, so this is out. Okay, so methane actually shares how many? 4. Right, let's draw the thing. Methane will look like this. Then it will be something like that. And this hydrogen, okay. So then water will be oxygen in the middle. Then it will look like that. Okay. Wait, in this, like that, yeah. Something like that. So I have no space. Like usually it should be like that. Okay. We are not measuring the angles today. So because this is O-level chemistry. Again, how many shared? It has 4 shared, so answer should be hydrogen. Okay, this has 1, 2, 3, 4, 5, 6, 7, 8. This has 8 electrons shared. You see, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the answer should be D, water. Pair of statements about diamond and graphite is correct. Okay, they are both pure carbon. Okay, that's correct. They are macromolecules. I wouldn't call them a macromolecule. I'll just call them, okay, rather giant molecular compounds. Giant covalent molecules. Okay, I will not call them macromolecules, but some do call them macromolecules. So I'll just leave it as that first. Okay, diamond and graphite can be used as electrodes. Okay, graphite can be used as electrodes, but diamond cannot, because electrodes has to be an conductor of electricity. Okay, graphite has free moving electrons along its layers, because for example, there are electrons here, right? It can move along the layers, between the layers, in fact. Okay, however, diamond does not have that. So diamond is basically cannot conduct electricity, so it cannot be used as an electrode. So unfortunately, B is wrong. Okay, diamond has covalent bonds. Yes. Okay, graphite has ionic bonds. This is wrong. Okay, graphite has both van der Waals forces, okay, which is basically this weak intermolecular forces of attraction. Okay, and then it also has this covalent bond. So unfortunately, this is wrong also. Okay, answer should be A. Yeah. Okay, diamond is hard with high melting point. It's hard. Okay, graphite is soft with a low melting point. Okay, graphite does not have a low melting point. It does not have a low melting point. In fact, its melting point should be high melting point. Okay, graphite, because graphite and diamond are both, again, macromolecules, or what in our syllabus known as giant covalent molecules. Okay, so each answer should be A. Okay, which of the following contains the greatest mass of oxygen? So what do? We just find the number of moles of oxygen, because the moles of oxygen is directly proportional to the mass. So what it means is that if I have the number of moles of oxygen, as this is the mass of oxygen, okay, as the moles increases, the mass increases linearly. Okay, so means as I have, for example, I have 1 mole, I will have 16 grams. If I have 2 moles, okay, I will have 32 grams of oxygen. 32 grams of oxygen. So yes, so this is how it works. So we basically just find the most number of moles of oxygen. Inside here there are 9 in one molecule, so total there are 1.8 moles of oxygen in this amount of aluminum nitrate. Potassium sulfate, there are 4 atoms in one molecule, so there will be 1.2 mole in this amount of potassium sulfate. Sodium nitrate actually has 3 atoms, 3 oxygen atoms in one molecule, so there will be 1.2 mole. Okay, 0.5 mole of magnesium carbonate actually has 1.5 mole because there are 3 each atom, so I take 3 times 0.5, so this is how I calculate it. 3 times 0.4, so this will be 4 times 0.3, I mean 9 times 0.2, so the answer should be A. Okay, because it has the greatest number of oxygen atoms inside, so hence it will have the greatest mass of oxygen. Okay, compound A has a composition of this. Okay, nitrogen, we all know that nitrogen has a RMM of 40, and then MR of 40, and then oxygen actually has a molecular mass of 16. So 36.4 over 16 will give you, should be about let me get calculator. Okay, 36.4 divided by 16, it will be about 2.275. This will be 63.6 divided by 14, 4.54. So we can clearly see that this is actually twice the ratio. So there will be 2 nitrogen atom in 1 oxygen atom. Okay, so it will be 8. Okay, calcium carbonate reaction. Okay, this kind of questions we will usually find the limiting reactant. Why is the limiting reactant? Basically, we find out how many moles of calcium carbonate are there. Calcium actually is 40, carbon is 12, oxygen is 16. So total, there should be, it should be a relative molecular mass of 100. So in 10, so how do I do it? How do I find RMM? 40, which is calcium, relative molecular mass of calcium, or no, relative atomic mass of calcium, okay, plus 12, relative atomic mass of carbon, and then plus 316, which is the relative atomic mass of oxygen. Okay, so this will give me 100. Okay, so number of moles of calcium carbonate, okay, I'll just write short for moles of calcium carbonate in 10 grams, it will be 10 divided by 100. Okay, it will be 0.1 mole. Okay, 1 mole is reacted with 100 cm3 of this. So in 100 cm3 of 1 mole per dm3, so how many moles of hydrogen are there? Mole of HCl will be equals to 1 times 100 over 1000. Bear in mind that 1 dm3 is equals to 1000 cm3. Okay, so it gives me 0.1 mole. Okay, and again we'll come back to this equation. I have 0.1 mole of this. Okay, I have 0.1 mole of this. Okay, however, this is actually a 2, so means for every 2 moles of hydrogen chloride reacted with there will be 1 mole of calcium carbonate reacting with it. So essentially, since I have only 0.1 mole, I can only accept 0.5 mole of calcium carbonate reacting with hydrogen chloride, because it must always fit the ratio. Okay, so basically, if both of them are 0.1 mole, it's either 0.1, so basically it's just 0.05 mole and 1 mole. Okay, so which is the limiting reactant again? Hydrogen chloride is the limiting reactant, because I have excess. I have 0.1 mole of calcium carbonate, however I only use 0.05 mole, so this means I have excess 0.05 mole. Okay, again I have excess calcium carbonate. Okay, so 1.2 mole of carbon dioxide is formed. Carbon dioxide is actually just take 24 dm3 times how many moles? Okay, so this is mole ratio of 1, mole ratio of 1, so this means that I will have 0.05 mole of carbon dioxide, and then this will give me 1.2 dm3. Is this answer correct? This answer should be correct. Okay, 5.5 grams of calcium chloride is formed. Calcium chloride has a relative molecular formula of 40 plus 35.5. Okay, so 35.5 times 2 plus 40, so it's 111. Okay, 111. Okay, so 111 grams per mole. So calcium chloride, how many moles of calcium chloride? Again, 0.05, because the ratio between calcium chloride and calcium carbonate is 1:1. So times 0.05 mole. So to calculate this, I'll get 111 times 0.05 mole. I'll get 5.55 mole. So 5.55 grams. So is this answer correct? This answer is correct. Okay, 0.4 carbon dioxide grams of carbon dioxide is formed. We know that 1.2 dmq of carbon dioxide is formed. So to find the number of carbon dioxide formed, 2 in grams will be equals to, what's CO2's relative molecular mass? We'll take 12 plus 2 times 16 times 1.2 dm cube is basically just equals to 0.5 mole. Okay, so 12 plus 2 times 16, 5. So I'll receive, give me a sec. Oh yeah, okay, this is not 0.5, should be 0.05. It should be around 2.2, which is not this. Okay, no calcium carbonate is left. Okay, again, calcium carbonate is excess, so there will be calcium carbonate left, so this is wrong. Answer should be 1 and 2. Okay, the reaction for the conversion of, okay, we don't really need to know this. Again, we find the moles of bromoethane, so we take what, 10.9 over 109, so 10.9 divided by 109, so this gives me 0.01 0.1 mole of bromoethane, and then we have 3.45 grams of ethanol. Again, percentage yield is always in mass. Always. This is by default in our O-level syllabus. When they ask you to calculate a percentage yield, it's always in mass. So you're finding the percentage mass of ethanol over the predicted yield. Okay, the predicted yield of ethanol should be, since there's 0.1 mole of bromoethane used, there will be 0.1 mole of ethanol produced. So the mass of the predicted mass, predicted ethanol mass in grams will be 46 times 0.1, which is 0.6 grams. However, I only have 3.45 grams. 45 divided by 4.6. So to calculate the percentage yield equals to 3.45, 4.6 times 100% will give me 75%. Answer should be, percentage yield should be C. Okay. Concentrated equals whatever. Okay. Electrolyze using inert electrodes. Answer, okay, A. Okay, so let's just draw it out. Okay, I have electrode here. Okay, using inert electrodes. So what happens to the electrolysis? That this is actually concentrated. Okay, so don't correct. ACl. Okay, oxygen is discharged at the anode. This will be the anode, and then, okay, so where is the anode? The anode will be this will be your anode, this will be your cathode. Okay, cathode will be the negatively charged one. Okay, so anode will be the oxygen is discharged at the anode. Is it true? No, it's not, because again, at the anode is usually the anion, right? Okay, the anion present is OH minus and Cl minus, but Cl minus will be preferentially discharged because of the concentration effect, because it's concentrated. So Cl should be the one discharged, so this is wrong. Cl gas will be produced. Okay, during electrolysis, the pH of the electrolyte increases. Again, this is it true? If OH minus, okay, OH minus remains because OH minus does not get discharged as discussed earlier. Cl minus is the one that gets preferentially discharged. If the pH increases, means it becomes more alkaline. Okay, when it becomes more alkaline, means I will have fewer hydrogen ions. So is hydrogen preferentially discharged? Yes, it is, because in the electrochemical series, sodium ion and hydrogen ion is placed lower than the sodium ion. Okay, so means hydrogen will be discharged to form H2 gas. When it forms H2 gas, then there will be a decrease in concentration of hydrogen within the solution. So this means that hydrogen more than, oh no, since there's a decrease, then it means hydrogen plus concentration. How do I write concentration symbol again? Whatever, concentration, hydrogen will be again OH minus. So eventually it will become alkaline. So this is correct. Okay. Explanation with the discharge of H plus ions, OH ions remain. The answer should be correct. The answer should be B. It should be B. Okay. Sodium's solid sodium is discharged at the cathode is wrong, because at the cathode again, the cathode will be this. The cathode will be this. However, do you think sodium is gonna be discharged? No, it's not. It's gonna be hydrogen. Okay, it's gonna be hydrogen. It's gonna be hydrogen. Products stay the same if equals sodium. Okay, now we are producing H2 gas, and also what else? Cl2 gas. Okay, if we replace it with sodium chloride, we're definitely only gonna get Na, not solid, liquid, molten, and chloride, which is in gas. Okay, so we definitely get chloride. Okay, definitely, but we do not get hydrogen. Okay, we do not get hydrogen because sodium is produced. Okay, so the answer is still B. Pair of metals are connected making a simple cell as shown below. Okay, again, reading all of these things, this comes. Okay, again, they say if metal 2 is more reactive than metal 1, the voltage measure is positive. So it means there's a specific direction. If metal 2 is more reactive than metal 1, so this means that this would be the anode, this would be the cathode. If metal 2 is more reactive. Okay, so it means the electrons will go this way. Okay, how do I know it goes this way? Because again, anode is oxidizing agent, so means it will actually release oxygen. Okay, from basically there'll be not oxygen, electrons released, so the electrons will move this way. This will be the electrons movement. Okay, so again, we see that cerium is actually more reactive than beryllium, because again, it's a positive. Remember, they said that if metal 2 is more reactive than metal 1, the voltage measure is actually positive. Okay, so this answer, the cerium will be the most reactive one. Okay, next followed by cobalt. Again, okay, if metal 2 is more reactive than if metal 1 is more reactive than metal 2, it will go the other way around. Okay, so again, now we know that what beryllium will be more reactive than cobalt because it's a negative. So if it's negative, it means that the electric current is moving the opposite direction. So instead of moving like that, this direction, it will move like that, because again, beryllium is more reactive than cobalt, and beryllium is placed as metal 1 for this situation. Okay, so again, beryllium, cobalt is more reactive than beryllium. Oh yeah, give me a sec. Cobalt is more reactive than beryllium. Is it? No, beryllium is more reactive than cobalt. Okay, cobalt, yeah. Okay, manganese. Okay, again, manganese. Okay, again, since it's negative, it will mean that metal 1 is actually more reactive than manganese. So means beryllium and cerium is both more reactive than manganese. So means manganese can either take this place or take this place. Okay. Or take this place. Okay, so since this is positive, it shows that manganese is actually more reactive than cobalt. So means it will have to take this place. Okay, so the most reactive one, we will start with cerium, then beryllium, manganese, then cobalt. Okay, so it will be this. It should be P. Okay, this is the energy profile diagram. Not profile. Energy level diagram. Profile diagram will be this. It will look like that. This is the profile diagram. So do not mix it up. This is energy level. This just shows you the energy of the level. Okay, describes the energy changes and the type of reaction. More energy is given out when a bond in products are formed. Okay, again, this is an exothermic reaction, right? This is an exothermic reaction because energy is released to the surroundings. Because here I have a lot of energy, but then my energy now go down already. So it means that energy is going out of the system. So this is the system. My energy is, for example, is a lot. Okay, then I give out all the energy. My energy become lower. Okay, this is exactly what it means. So this is an exothermic. So I'll take this. This is wrong. This is wrong. Okay, for an exothermic reaction, more energy is given out when the products are formed. Okay, exothermic reaction actually more energy is absorbed. No, more energy should be given out when the products are formed for exothermic. So answer should be B. Okay, nitrogen trifluoride. Again, this is just math. Okay, again, so what I would advise you all to do is just to draw it out. So N N F F F. So there will be 3 Fs. Okay, how about the NFF? So nitrogen trifluoride. Or something like that. So there are 2. Okay, so these are the reactants. These are the products. Actually, there's only one product. Okay. Yeah. So to add it up, you will get 950, which is from this. Then we will get 3 times 150 to cover this, minus 2 times 280. Remember, this is actually just for a single NF bond, nitrogen fluoride bond. Okay, there are how many? 1 bond, 2 bond, 3 bonds. Okay, so and then there are also 2 molecules. So total there are a total of 6 bonds. So I'll times this. So it will give me actually negative 280. If I'm not wrong, I just calculate it. 950 plus. Yep, minus this. So it will be kilojoules per mole. Answer should be B. Okay, marble chip reacts with hydrogen chloride in an exothermic reaction. Again, this tell you that the energy is moving out. Energy out. Exhaling. Okay. When excess marble chips are added to hydrochloric acid, the real reaction starts off fast, then gets slower. So basically, a typical reaction will go like that. Okay, so it will start off fast with its steeper initial gradient, then it will slow down. Okay, with the gradient becoming smaller. Remember, the steeper the gradient, the higher, the faster the rate. Okay, the concentration of hydrogen chloride is decreasing. That is actually true, because as you react, there's a limited number of hydrogen chloride. So means that in a certain volume, which means I add, for example, 1 dm cube. Okay, these are all my reactants, and maybe this is my reactant. Okay, I will have 3 moles, for example. Okay, in the same 1 dm cube, because unless the water evaporates, but most likely not, the water will not evaporate, I actually have 2 moles now. Actually, yeah, 2 moles now. Mole. Okay. Things of course reacted, so it became smaller. Okay, so now I have 2 moles of the solution. 2 moles. Okay, so this means that the concentration decreases. Okay, because this is 2 mole per dm cube. This is 3 mole per dm cube. This is 2 moles per dm cube. Because I react it and there's fewer reactants. What we call fewer reacting particles. Okay, in our O-level syllabus. So the answer should be A. The concentration of calcium chloride is increasing. In fact, it is not actually it's increasing. Okay, it's increasing because it's a product. But that does not justify why the reaction slows, because calcium chloride is not the reactant. It does not affect the rate of reaction at all. Okay, in our syllabus, it does not affect the rate of reaction. Okay, calcium carbonate is completely used up. Again, it's excess, so this is definitely not true. Temperature mixture decreases. Again, it's not true because it is an exothermic reaction. Exothermic reaction means, okay, for example, this a bit confusing. Okay, this is my substance, my reactants. Okay, okay, reactants okay. When I react, right, the energy will come out. So this is actually my water. This is my water. reactants. The energy will come out from the reactants. Okay, so basically my water will increase in temperature. Okay, it will increase in temperature because the energy from the reactants come out to the water, which is the water is basically your surroundings. Okay, the water is not the reactants. The energy does not come out here. Okay, a lot of misconception is that a lot of students misunderstand this. Yeah, they are still misunderstanding this situation where they think that the energy being lost is from the water. So it means that they think that energy is lost from the water, so the surroundings or surrounding air, I should say, increase in temperature, and then the water decrease in temperature because the water is losing energy. Again, that is not true because the water is not reacting. The reactants in the water is reacting. So when the reactants in the water reacts, okay, energy will be lost to the water, will be released to the water because it is an exothermic reaction. The water does not lose energy. The water is not reacting. Okay, the water is just imagine the water is air and you're reacting in air. Just imagine water is a medium where you react. Okay, so the energy is coming out from the reactants, not from the water. So the water increases in temperature. It does not decrease temperature. Okay, the water increase in temperature. Okay, I repeat, the water increase in temperature because energy from the reactants is being released out. Okay, not from the water but from the reactants. Okay, so next, this again, about rate of reaction again, this should be the easier ones. Okay, large piece, small piece, usually this will be the smaller rate, lower rate. Okay, this will be the higher rate. Okay, large pieces of magnesium are used but the concentration of acid increases. Again, here they said that the reactor with the same volume of sulfuric acid, okay, at room temperature. So for example, I have 1 dm cube of sulfuric acid. Okay, I use more, concentration increases of the acid increases, so means I have 1 dm cube but inside is actually 3 moles. Then okay, so that's for experiment 1. For experiment 3, I have 1 dm cube but the concentration of the acid increases, so it will be 4 moles per dm cube. I have more now. Okay, I have more now. Again, magnesium is in excess. So what does this mean is that all the sulfuric acid will react. Okay, so all the 3 moles of sulfuric acid here will react. All the 4 moles of sulfuric acid here will react. Okay, so essentially there are 4 moles of reacting, 3 moles reacting. 4 moles will yield higher volume of gas. So that's why experiment 3 should be W. Okay, I teach you a trick. Okay, whenever you see these kind of questions, right, you see over here W, right, where there's X and Y and this double of the same thing, W and W, it is most likely one of them, so you can eliminate the other ones. They are both the same and this works sometimes. Okay, so this is just a way to check. Okay, so to make you more confident during the examination. Okay, W and W is the same, so it's most likely between these two choices. Okay, so again, experiment X has a steeper initial gradient. Experiment Y has a gentler initial gradient. X has a steeper initial gradient, so it means that X will be the smaller pieces. So X should be experiment 2 because smaller pieces increases the surface area. Surface area is the volume. Okay, maybe it's the same mass. Is it the same mass? Yes, the same mass. Okay, so it means it increases surface area to volume ratio. So it means that more acids in contact with magnesium. Okay, so it means that the reaction will be faster, so the answer should be experiment 2 will be X, so it should be this, D. Okay, take some time, take a pause if you need to. Again, here this will be the last question and then we will move on. I'll record another separate part. Okay, the statement describes what happened in this reaction. Carbon is oxidized. Is carbon oxidized? No, it's not, because oxidized means it's the gain of oxygen. Okay, carbon in fact is reduced. Okay, magnesium is reduced. Is it reduced? No, it's not, because it gains oxygen. Reduce means you remove the oxygen again. Reduce means reduce the number of oxygen. Okay, so in fact this is wrong. Okay, neither oxidation and reduction occur. No, this is actually a redox action. So both oxidation and reduction both of them have occurred. Okay, Carbon in carbon dioxide is reduced, is it? It is in fact reduced because there's a loss of oxygen. And also we can check the oxidation state. This is actually a +4 oxidation state. This is actually a 0 oxidation state. So is it reduced? Yes, because there's a decrease of oxidation of state of 4. So answer should be D. The rest of the questions we will go through in a separate video named part 2.